S of t equals 0.03 t squared plus 2t plus 9 is said to give the position S of some object at a clock time t, at the time when the clock reads t. So, position in centimeters, clock time in seconds. S, position, t, clock time. Okay, so S of 2 equals 13.12, as you can easily find by plugging 2 in for t. T squared is 4, 4 times 0.03 is 0.12, 4 times 2 is 4, 9, 9 and 4 is 13, we add 0.12, we get 13.12. Shouldn't need a calculator to evaluate that. Now, S of 2 plus 0.01 is 13.1412 approximately. Now, you probably would use a calculator to do that, although if you know the binomial theorem, you could easily square 2 plus 0.01. It's going to be 2 squared plus 2 times 0.01 plus 0.01 squared. Anyhow, you get something pretty close to 3.1412. And actually, I'm going to stop a second. Okay, sorry for the interruption. So, what is S of 2 plus 0.01 minus S of 2? Well, S of 2.01 is this. S of 2 is this. If we subtract this from this, you can see, and you should be able to do this very easily in your head, you get 0.0212. So that S of 2 plus 0.01 minus S of 2 divided by 0.01 is going to be approximately 0.0212 over 0.01, and that is going to be, and again, this is something you should be able to do in your head very easily, 2.12. Now, what are the meanings of these things? What does this mean? What does this mean? What does this mean? What does this mean? In terms of the fact that S is a position in centimeters at clock time t in seconds. Well, S of 2 means that now t is equal to 2. It means that your clock time reads 2 seconds, and your position S at that time is 13.12, meaning 13.12 centimeters. So this means that at the 3.12 centimeter position, the object is at, let me complete my sentence, I'll just say the object, whatever the object happens to be, is at 3.12 centimeter position when the clock reads 2 seconds. That should be very clear. Now, without looking at the interpretations I have here, you should stop and think about what the interpretation of S of 2 plus 0.01 is. Well, you should have done that, and you should have thought it through without looking. Maybe you've looked by now, after thinking it through, I would hope. 2 plus 0.01, of course that's 2.01, but I wanted to write it 2 plus 0.01 to connect it with other calculations we did in the preceding class. That means the clock is reading 2.01 seconds, and when it is, the position, or if the clock is reading 2.01 seconds, the position is 3.1412 centimeters. So, this says the object is at, abbreviate object, the object is at 13.1214 centimeters when the clock reads 2.01 seconds. Now, the question marks here are a vestige of the fact that I had blanks and question marks, so I presented all these calculations first as questions in class. So let me get rid of the question marks because they might be a little confusing. There is no question mark at this point. Okay, just got rid of a couple of question marks and repositioned that 0.0212. There was a blank there to be filled in. It was a little high. Okay, looks a little better now. So, what does S of 2.01 minus S of 2 mean? Well, S of 2 plus 0.01 is the position here when the clock time read 2.01 seconds. S of 2 is this, the position when the clock time read 2 seconds. When we subtract these, we get the difference between the t equals 2 position and the t equals 2 plus 0.01 position. And this says that the difference is 0.0212 centimeters. Now, that interpretation should be fairly clear. Now, you should really try to think through the interpretation of this, not looking ahead, especially if you're one of my physics students. And I just pointed to the thing I didn't want you to look at. That probably wasn't a good idea. Okay, we have S of 2 plus 0.01 minus S of 2. Now, hopefully you stopped and thought about this. But what is this? Well, this is the 0.012 centimeter. It's the difference between this position and this position. It's the change from this t equals 2 to the t equals 2.01 position. It's how far the object moved during that 0.01 second time interval between 2 and 2 plus 0.01 seconds. What's the 0.01? Well, that's the difference in this clock time and this clock time. So we're dividing the change in the position by the change in the time on the clock, the change in the clock time. And we can get then change in position is 0.0212 centimeters divided by 0.01, that would be in seconds. And we get 2.12 centimeters over seconds. What's that mean? Well, again, the numerator is the change in position in centimeters. The denominator is the change of clock time in seconds. And at this point in the class, my physics students kind of saw a light bulb come on because we've been raving about this for a month. Okay, this then is the average speed or velocity. I'm not going to make that distinction in this course at this point. In centimeters per second. Okay, and I've used the analogy, if I drive down the interstate, if I drive 140 miles in 2 hours, what's my average speed? Now, I said that if I go from mile 14 to mile 154 in 2 hours, what's my average speed? Well, people immediately, okay, subtract, that's 140 miles, and you're doing it in 2 hours, so that is 70 miles an hour. Natural calculation. What did you do in that calculation? You took my change in position, this time in miles, from the mile 14 to mile 154, and you divided that by the change in clock time in hours this time, 2 hours, and you got the average speed. 140 miles divided by 2 hours is 70 miles per hour. So that one was in miles per hour, this one's in centimeters per second. This is the obvious calculation you do when you calculate a speed in a situation like I mentioned. Okay. So that's very important. This is, again, a change in position divided by a change in clock time. That's an average speed. That's exactly what's being represented here. Now, you should see at this point the connection between this expression and the expressions we simplified in class the last couple of times. This expression here is an instance of what we call a difference quotient. You've already seen it as f of x plus delta x minus f of x divided by delta x. I'm using numbers here instead of x's and numbers here instead of delta x's. But this is a difference quotient. And you should think about where we're heading with this.